Today we're going to be working on elementary cases with your exponential equations, meaning that we are solving exponentials without the use of a logarithm. So let's take a look at a few of these. So I'm actually going to have you try to pause the video, see if you can work some of these out. Same thing here, pause and work them out, and I'll show you the answer key. First, start with some of the basics like number 4. Let's say number 7, perhaps number 11, and number 12. So that's where I'm going to start, and then hopefully it makes a little sense. Maybe even number 8 as well. I'll throw that one on there. So let's take a look at this one. When it comes to an exponential equation and trying to solve it, we want to make sure first that your bases are the exact same. Your base is what these are going to be like multiplied by however many times, and then these being your exponents. So this is how many times you want to be multiplying your base out by. Now, because your exponent is now up in the above, right, we don't know exactly how many times we want to multiply these out or what your value actually is. So in our case, we want to make sure that your bases first match and they're on either side of the equation. And then once they are, we can go ahead and ignore them and just look at your exponents. So you have 2a is equal to negative a, and we want to solve for your variable. So solve and get it alone into one side. Now, because these variables are the exact same already, we can go ahead and add a to the other side. So you have 3a is equal to 0. Therefore, a has to be equal to 0. And we can check by plugging that back in. So we're just saying that we're assuming that a is now equal to 0. So 3 times 2 times 0 is equal to 3 times negative 0. Well, anything to the 0 power, because it'll be 0 on both sides. And notice that they are already equal, but anything to the 0 power is going to be equal to 1. And because both sides of the equation mean the same thing, we have it correct. Let's try another one. Let's try number 7. So once more, we want to make sure that your bases start off as the exact same and they're on either side. Then we can go ahead and allow everything to drop. We have negative 2a is equal to 2 minus 3a. We want to now start to solve for your variable. So let's add 3a over. So we have a is equal to 2. So let's go ahead and check that this is correct, that a, we believe it to be 2. So 6 to the negative 2 times 2 is equal to 6 to the 2 plus 3 times 2. So to simplify, we have 6 to the negative 4th is equal to 6. 2 minus, let's see, 3 times 2 is 6, which is then to the negative 4th. And again, they mean the exact same thing on either side. So we don't actually have to go ahead and multiply 6 to the negative 4 times. Let's try another one. Let's try this one over here. Right, so this one is a different take because we have a couple things going on. We now have another base when we're normally having one of base on either side. We also have this 10 that's in the denominator. So first thing to do is to try to combine these to get to one particular base. So thankfully, these 10s are already the exact same. We don't have to work too hard, but keep in mind when we have x to the a times x to the b, what do we normally do to your exponents? Well, we go ahead and we can add your exponents together. Even though there's multiplication between the two of your bases, right? Your bases are the same. We can go ahead and add your exponents. So for these, right, we're going to add negative 3x plus x to make 10 to the negative 2x. Now on the other side, right, to have 1 over 10, if we raise it up into the numerator, so right now if we had x or 1 over x, to raise it to the numerator, we have x now raised to the negative first power. It's positive when it's down below and it's on its own, but when we raise it up and change its position, it's now negative. Same thing, if it's negative above, we can put it in the denominator and put it down. So then we have 10 to the negative first power. Now, because your bases now match, we have negative 2x is equal to negative 1. Solving for x, we can go ahead and divide by negative 2 to get 1/2 and a positive 1/2 at that. And again, if we want, you can always double check your answer by plugging it back in and evaluating. Let's do the same thing over here. Let's erase a little bit. So we have 3, and thankfully they're all with, they all have a 3. So again, a little bit less work from us. We have negative 2x plus 1, and we want to combine your exponents through addition. So say plus this negative 2x minus 3 is equal to 3 to the negative x. So now that we have your bases that are the exact same, we can go ahead and say this is really negative x plus 1 minus 2x minus 3 is equal to negative x. And I would have simplified before I did this point, but it doesn't matter here. We'll make a negative 4x minus 2 is equal to negative x. Negative x will add 4 to the other side, so we get 3x. Therefore, x is equal to negative 2 over 3. And again, we can plug it right back in as we've done before to double check our answers. And I noticed that I missed one from above, number 8, so we'll go ahead and do number 8 as well. So our bases thankfully match. We have these to drop. We get 2x plus 2 is equal to 3x. Let's go ahead and subtract this 2x to the other side. We get 2 is equal to x. And let's go ahead and check your answer because we haven't checked one in a little bit. So we have 2 to the 2 times 2 plus 2 is equal to 2 to the 3 times 2. So we get 2 to the 4 plus 2 is equal to 2 to the 6. 2 to the 6 is equal to 2 to the 6. And that means the exact same thing. I'll do a few more on the next page, and I'll try to do the ones that do not have the same base. So we'll start off perhaps with 13. We'll do 15 here. We'll do 19, 20, and 21. So I'll do a few more on this page so that you guys can get into the hang of it. All right, you'll notice that on one side, we have a base of 4, but thankfully they both have the base of 4. So we can go ahead and add their exponents together. So you get 4 to the x on one side, and actually that's a negative x, my apologies. And on the other side, we now need to get 64 to have a base of 4. So 64 can be rewritten as 4 to the what power? Well, it would be 4 to the third power. Now that we have matching bases, we can go ahead and drop your exponents. So we have negative x is equal to 3. Therefore, x is equal to negative 3. Now let's go ahead and check because we haven't had a negative exponent before. So we have x to the, let's see, negative 3 times 4 to the negative 3 is equal to 64. So we have 4 to the 6 times 4 to the negative third is equal to 6. So we have 4 to now the positive 3 because we get to add those two together and that actually equals itself. Let's go ahead and try 15. And again, we haven't had one in a little while. We have something in the denominator. So let's go ahead and bring that up into the numerator and then give it a negative exponent. Now 32, how can we have 32 to get the same base as 2? Well, 32 is really 2 to the base of 5. Let's go ahead and add your exponents together. So we have 2 to the x plus 5 here is equal to 2 to the 5th. Then we can ignore and have x plus 5 is equal to 5. Subtract, we get x is equal to 0. So let's see if that is true over here. So let's go ahead and check. So we have, oh, and I actually dropped a negative along the way. So notice that I went from here to there. So let's redo that now that I know my answer is incorrect. And notice that by checking as well, you're going to see if you did make a silly mistake as I did. So we have really negative 5 here. That will be a negative 5. So then we have x minus 5 is equal to 5. We can add that 5 to the other side and get 10. So now let's go ahead and check. We have 2 to the 10 times 1 over 32 is equal to 32. Well, really, if I were, and again, I'm under the assumption that maybe I don't have a calculator here, we could say really, this is 2 to the 5th times 2 to the 5th over 32 was also 2 to the 5th. We have 2 to the 5th over here. So one of these cancels with the other, and I'm left with 2 to the 5th is equal to 2 to the 5th, which is a true statement. And let's say I was under assumption that we had x is equal to 0. Well, that just means that anything to the 0 power is 1. So 1 times 1 over 32 actually is not the same thing as 32, while it looks rather close. We're off by a little bit. So again, checking your answer is super, super important. Let's try 19. 19, we have a whole lot of different bases. So we need to figure out what the best base possible would be. So while 9 can use 81, so 9 squared can make 81, the same rule doesn't apply for 27. So instead, perhaps we can put everything in a base of 3. So 3 to the what power makes 81? Well, 3 to the 4th is 81. 3 squared is equal to negative 2b minus that is equal to 3 cubed to make 27. So now that all of your bases are the same, we want to start to combine the ones on the left-hand side. And if we want to as well, we can say 3 to the 4th times 3 to the negative 4b. And all I'm going to be doing is distributing this throughout the expression. And now we can go ahead and combine through addition. So we have 3 to the negative 4b. We have 4 plus a negative 4. So we just have a negative 4b is equal to 3 cubed. Your bases are the same. Now we have b is equal to negative 4b is equal to 3. Therefore, b is equal to 3 over 4. And that one is negative. All right, let's go ahead and we can again check your answer here. This one being an unusual one, I want to at least do one of those. We have 81 times 9 to the negative 2 times negative 3 over 4 minus 2 is equal to 27. So this part is, let's see, negative 2 over 4 is really, now it's a positive because it's the negatives are going to cancel. Then 2 cancels with the 4 and we're left with a 2 down below. So we have 3 over 2 minus, and then if we wanted to change this one into a base or a fraction, so we have minus 2 minus 4 over 2. So we get negative 1/2 here. So we get 81 times 9 to the negative 1/2 is equal to 29. So let's keep chipping away at this one. So because it is a function, or it is a fraction and it's negative, let's put this down below. We have 81 over 9 to now the positive 1/2, which can be written as 81 over the square root of 9. Because of the square root, if we have the square root of a and b on the inside, we can rewrite it as a fraction, a on top, b to the bottom. So then we have 81 divided by 3. 81 divided by 3 is actually 27, which is equal to 27. So that checks out. So once more, let's do, I think we only have a couple more. Oh, let's do 20 before I move on to the other one. So again, these ones, your exponents here, we can do a 3. Oh, and I didn't even change it. We have squared -3 squared x. And if you wanted to, you didn't even have to. You could, if you wanted, if I were to backtrack, make my life a little bit easier, I could say this is 9 to the -3x plus x is equal to 27. 9 to the -2x is equal to 27. Now we can go ahead and change your bases. Squared -2x, 3 cubed. So we now have -4x is equal to 3, x is equal to 3 over 4, and again a negative. All right, let's go ahead and check 21. So 21, we now have your 1/6. It's in the denominator, so when we rise it up into the numerator, we have a negative exponent, 3x plus 2, and I'm going to put parentheses around that, times, and then maybe we have to figure out, okay, 216 can be made into what as your base. So we could figure out, okay, well, because there's a 6, most likely that's some sort of a tip off. So we know 6 squared is 36. So maybe 6 cubed, or sorry, 6, cubed is perhaps the one to go. And that is actually correct. We have 6 cubed here is 216. Again, this one is in the denominator, so let's bring it up. So this is really 6 cubed, and we'll bring it up. So now it's a negative. So let's combine. So we have 6 to the -3x minus 2 times 6 to the 9x is equal to 6 to the -3. Let's go ahead and add the ones on the left. We have -3x minus 2 plus 9x is equal to 6, -3. We'll add those x terms together. We get 6 to the 6x minus 2 is equal to 6 to the -3. Taking a look at your exponents here now. We have this, add 2 to the other side. So adding 2 to the other side, we still have a -1. So x is equal to -1/6. All right. That I think concludes our video. Again, check your responses as best as you can, as often as you can.